What is grooving, everyone? Welcome back to an episode of Beau Maths. And today we're going to be starting a new series on the fundamentals of algebra. So in this series, we're going to be covering different topics of algebra, as well as in these first few videos, kind of covering a lot of the preliminaries that are needed to really understand algebra effectively. And that's what we're going to be starting with today here. But before we get into that, I think we should start with talking about something that's very important for understanding mathematics and doing problem solving, and not even just problem solving in math, but problem solving in general, whether you're in sciences or trying to just, I don't know, even build something in your garage, right? There's always problems that occur and different ways that you can solve the problem. So perspective, I believe, is incredibly valuable to have when it comes to being an effective problem solver. The reason for this is that you can kind of look at a problem from multiple different ways, and this is a skill that I think is crucial to develop. As an example of this in mathematics, if I asked you this question, what is addition? What would you say? Go ahead, pause the video, and actually answer what you think addition is. And once you've done that, can you explain to me in a different way what addition is? And once you've done that, can you do it even more ways? How many ways can you explain what addition is? All of these are different perspectives on what addition is. So for example, let's say I have a heart, and then I have two more hearts. When I add these together, basically I'm saying that I have three hearts in general, right? So I have one heart, two more hearts, I combine them, I get three hearts. So this perspective on addition is basically totaling how much stuff we have. Right? I have one heart, I have two hearts, but in total I have three hearts. Another way of doing it, maybe a little more abstractly, is just, it's a way to combine numbers. So via addition, how do I combine 1 and 2? Well, they combine into 3. And this maybe is less satisfying to think about than kind of combining objects, because this is the way we learned about it. But whenever you're adding numbers, at this point, you shouldn't really be thinking about objects. You're usually just thinking, okay, I combine 1 and 2, they make 3. This is how we are using addition in our everyday life in this kind of abstract sense. So that is just, this perspective is a way to combine numbers. Another more visual method that some of you might have come up with was using the number line. Now, the number line is kind of a way to represent all of the numbers that we have in a nice space like this. And so we can kind of visualize all of our numbers where we're writing them in a given order, where they get bigger to the right, positives are to the right of 0, negatives are to the left of 0. And it's not just these whole numbers, we also have things in between. For example, in between 0 and 1, we have numbers like 0.5, or maybe over here we have like 0.9, right? So we can have numbers in between this, so it's a continuous or a way to represent all of our numbers. And these arrows on the side just mean that this goes on infinitely. So after 10, of course, comes 11 and then 12. Those are technically on the number line. I'm just not writing them here because, well, I can't write infinite numbers on a page, right? So that's where these arrows come in, just to represent it goes on forever. And that's commonly used in mathematical diagrams. All right, so the way we can represent addition using this is we start at 1. All right, so I'll draw this red dot above the 1 here to represent that we're starting at 1. And then we take 2 steps in the right direction. And that represents us adding 2. And where we end up with is our answer. That's 3. So another way of representing addition is simply by movement on the number line. And hopefully these are things that you are all familiar with. Because now what we're going to do is maybe a new way of looking at addition that you potentially haven't seen yet. And that is going to be moving the number line itself. So just give me a moment here. I'm going to draw a couple of number lines and I'll show you what I mean. All right, I could fill in more numbers, but this will work for now. So let's say I wanted to add 2 to the entire number line. Well, what do I mean by this? Well, what I'm going to do is I'm going to take this number line and I'm going to shift it over by 2 to the right. So 1, 2. All right, so this, oh, my hands are getting stuck here. So this will be our shifted number line, +2, like that. All right, but notice, what do things line up with? We see that 0 lines up with 2, 1 lines up with 3, 2 lines up with 4, and so on. We could also go over here and look at -1 lines up with 1, -2 lines up with 0, and so on. So what we end up getting is that every single number on here corresponds with itself +2. For example, 0. How did we get to 2 from 0? Well, we add 2, right? So we get that 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. And so by just shifting this number line and comparing it to the old one, we didn't just add 2 to one of the numbers like we did in this method up here. We actually added 2 to all of the numbers. All right. And so if we focused on just one number, for example, if we focused on 1 here, so what I'll do is I'll put it back to how it was before, and then I'll slide it over by 2. Where does 1 end up? Well, 1 ends up with 3, which should make sense because 1 plus 2, which is what we did to this number line here, gives us 3. And so this is another way that we can visualize adding 2. But what's more powerful about this is if I said, hey, what if I started at 4, let's say, right? So I start at 4, and then I add 2 to my number line. So 1, 2, what does that correspond to? That corresponds with 6, because 4 plus 2 equals 6. So what we end up getting then is that we have kind of another way to visualize addition, but rather instead of addition kind of within a number line, we're looking at addition as being something that moves the entirety of the number line. So let's try another example of this. By moving the number line, solve 1 plus 3, 2 plus 3, -4 plus 3. So pause it and give it a shot. All right, so let's try these out. So we'll start with looking at 1 plus 3. So we'll note that 1 is right here on our number line. And for 2 plus 3, we have 2 right here on our number line. And for -4 plus 3, we have -4 on our number line. So all of these have in common is that they are being added by 3, right? So what we'll do is we're going to add 3 to our number line here. So what that means is we'll move it over 3 units. 1, 2, 3. All right, perfect. So let's see where everything lines up. This -4 here lines up with -1. This 1 here lines up with 4. And this 2 here lines up with 5. So what this then tells us is that -4 plus 3, which is what we did to the number line, is -1. 1 plus 3, which is what we did to the number line, is 4. And 2 plus 3, which is what we did to the number line, is 5. So we then get our answers as 2 plus 3 is 5, like that. 1 plus 3 is 4, like that. And -4 plus 3 is -1. All right, so you may be wondering, okay, this is kind of interesting, but what's the point? Why do we care about this perspective? The reason that this might be useful is that it gives us a way to visualize an operation of adding 3 to not just single numbers, but to an entire space of numbers. And this becomes very useful in things like physics or thinking about more real world problems, because in the real world, it's not just a single point, like in this case here, it's not just a single point that moves, but a whole collection of points or a whole space of points. For example, if I take this pen here, I'm not just moving a point when I'm moving the pen, but I'm moving all the collection of points that make up the pen, right? You can think about it as all the atoms or the molecules that make up this pen. I'm moving them all around, right? And so if we think about moving a number line instead of just a single point on the number line, that in a sense kind of represents us moving a whole space of things around. So if, for example, I said, I have this set of sticky notes here, right? And I'll go back to this example. And let's say I want to move this set of sticky notes 3 units to the right. Well, okay, I'll take our number line and I'll shift it over 3 units. 1, 2, 3. So that lines up with what we had before. But now we see that the sticky note, well, whereas before it was between -7 and -1, now it occupies the space that's more between -4 and 2, right? If we look at, kind of draw up there, right? The sticky note is now between -4 and 2. So if we think about how did the sticky note move, well, it moved from being between -7 and -1 to being between -4 and 2 because we added the sticky note by 3. And this is something we wouldn't have been able to do in this perspective, because we would have said, okay, I have this sticky note between -7 and -7 and 1 here. But the problem is it wants me to move a single point, but I have a big collection of points here. So this kind of allows us to manipulate whole groups of objects at once. And so I hope that through this perspective, you kind of learned how we can kind of think of addition in multiple ways, and that you found this interesting. And I think this tool is going to be very useful for explaining different algebra topics in the future. And in the next video, I'm going to provide some more examples for you to practice this. And following that, we'll use other operations on the number line. But feel free to think about it ahead of time. What would subtraction on the entire number line look like? What about multiplication or division? Try these out for yourself, and maybe you'll find something pretty interesting. But that about does it for today. Thank you for watching. Keep practicing. Have a good one. Stay groovy, and I'll see you in the next video.